Please welcome to the stage, co-founder of Anyscale, Robert Nishihara.
Good morning. Welcome to Ray Summit. Thank you so much for being here. What a great year for AI. Over the past year, billions of people have encountered AI, and so many of us here have put AI at the heart of our products. Over the next couple of days, you'll hear how Runway and Canva are transforming creativity, what Netflix and ByteDance are doing in entertainment, what Ford and Zoox are doing in autonomous driving, Tower Research in finance, Recursion in drug discovery, Roblox in gaming, and so many more. Over the past year, every business on Earth has realized that AI is central to its strategy. And this community here, building with Ray, has had a front row seat to that. How cool is that? Thank you. Ray now sees around 1 million unique clusters launched every single month. And my favorite stat, Ray recently crossed the 1,000 contributor mark to the open source project. Many of you are here with us today. Thank you so much for all of your help building this project. It's just been a massive collaborative effort. Now, many of you here are building AI platforms for your companies. So you know how powerful it can be when you can truly enable the latest AI capabilities throughout your organization. Right? Capabilities ranging from rapid iteration to massive scale, spanning classical machine learning and generative AI. Right? If you do your job well, you can enable every team internally to be an AI team. But you also know how hard it is to actually do that. Over the past 6 months, I've chatted with around 100 of you. And one message stood out very clearly. Complexity is blocking us. We're all clear on the potential. We all want to do this. But we're held back by complexity of AI. And my co-founder, Jan, will go into far more detail about the underlying trends driving this. But this is the complexity generated by scaling data. Not just more data, but new data modalities, text, images, video. Scaling compute. The proliferation of hardware accelerators, of AI frameworks. More and more AI being used for data processing itself. And growing complexity around post-training and inference time compute. None of this is going anywhere. And actually, it's going to get a lot worse. Of course, the potential is getting a lot bigger, but in parallel, the complexity is getting far worse. And this complexity is actually why we set out to build Ray in the first place. 2016. The aha moment for Jan, Philip, myself, and those of us who originally built Ray was just a similar version of exactly the same problem that we're seeing today. We were researching deep learning and reinforcement learning algorithms for our PhD at Berkeley. And the funny thing is we weren't actually doing research. We were spending our time managing clusters, or cobbling together distributed systems, or wrangling data. We weren't setting out to change AI infrastructure and revolutionize AI infrastructure. We were just trying to solve practical issues that were driving us nuts. But what we ended up building, this Python-first, flexible, seamless scaling approach, everyone we talked to who was serious about AI at the time needed to solve that problem. And so it caught on, slowly at first. The first serious Ray user was Ants Group. They contributed a ton to hardening Ray in production. And today they use Ray on millions of CPU cores, tens of thousands of GPUs for use cases ranging from batch inference to online learning to model serving and more. Uber was one of the next major Ray users, and Pinterest. Those two contributed to fleshing out the data ingest and pre-processing story for training, which so many of us use today and is so important for how we think about Ray's use cases. Today, they run tens of thousands of batch jobs, training jobs every month. But these were early adopters. Ray was still very young. The real inflection point for Ray came with ChatGPT and generative AI. Generative AI took the complexity problem and made it 10 times worse. It also made the potential and the promise 10 times bigger or more, but it made the complexity far worse. And as a consequence, Ray is now powering AI workloads around the world. The work this community is doing is truly bringing AI to life. Next, I'd like to welcome my co-founder, Jan Stoica, co-founder and chairman of Anyscale and Databricks, professor at UC Berkeley, to the stage to talk about the underlying trends driving this complexity and why Ray has become the underpinning of so many AI platforms. Please welcome Jan.
I'm thrilled to be here. This is really a historical moment for AI, which means the need for Ray is only growing. The complexities that leading researchers like Philip and Robert were facing in our lab almost 1 decade ago has become the norm for AI developers at every enterprise today. I know you all feel this. The complexity has become overwhelming. So how did we get here? Let's do a quick run through the modern compute history. As you know, I'm a professor, so I cannot help myself. 2 decades ago, we saw the rise of big data and classic machine learning workloads. These workloads require large clusters to scale data and machine learning processing. However, these clusters are homogeneous, consisting of more or less identical machines. This is a Hadoop and Spark story you all know well. 1 decade ago, we saw the rise of deep learning and reinforcement learning workloads. Machine learning platforms came to the fore. GPUs started to become indispensable. Then, 5 years ago, Gen AI. I'll go into more details on this one, but there are 5 trends to keep in mind. First, scale. The compute requirements to train state-of-the-art model has grown over 5 times every year. This has been driven by the scaling law, which simply says that more data and more compute equates better models. Correspondingly, the cost of training, as you can see here with GPT, has increased more than 1 order of magnitude every 2 years. And it's not only the large language models. The smaller models themselves are much larger than their predecessors. And it's not only training, also inference. Recently, OpenAI released the most advanced reasoning model where the context can be orders of magnitude larger than before. It may take tens of seconds just to answer a single question. This is the beginning of a new scaling era for model inference. Second, massive unstructured data. Text, audio, images, video. These data modalities, which are inherently much bigger than structured data, have become increasingly critical. Video companies building foundation models like OpenAI with Sora, or Genmo and Runway, are processing millions of images and videos every day. And Pinterest and Apple, who you will be hear from later today, are processing petabytes of multimodal data to power their GenAI applications. And it's not just large language models. The unstructured data story also applies to traditional models. Third, sophisticated post-training. Training no longer means just pre-training and fine-tuning, but model pruning, distillation, merging, reinforcement learning, and more. Fourth, AI is used to build AI. By that, I mean that AI is being increasingly used to optimize every aspect of model development, from data preprocessing to synthetic data generation to automatically partition models across multiple GPUs. Each part of the AI stack is itself becoming AI-powered. Fifth, in actual enterprises, we are not talking about just one model. We are talking now about compound AI and agentic systems that involves tens, even hundreds of models, including not only large language models, but also traditional predictive models and more. Compound AI systems only increase the pressure on the underlying AI infrastructure. To summarize, the trends are scale, multimodal data, sophisticated post-training, AI powering the AI stack, and compound AI and agentic systems. These developments put enormous pressure on the underlying infrastructure to evolve. The result, innovation, of course. Above all, hardware accelerators. Just 5 years ago, if I said GPU, we would be largely talking about a single GPU model from NVIDIA. Now, one will be talking about which GPU. We have not only NVIDIA, but AMD, Intel, and every superscaler with its own accelerators. And even when it comes to NVIDIA, now we have H100, A100, A10, L4, and much more. Moreover, to support bigger and bigger models, we are rapidly moving from single server GPUs to pods with hundreds or thousands of tightly connected GPUs. And when it comes to using the resource efficiently, we need to decouple the CPU and GPU allocation to best fit each application demands. In summary, we are witnessing a historic transition from a CPU-centric to an accelerator-centric world. In addition, we are seeing the emergence of AI-focused clouds like CoreWave and Lambda Labs, dozens of new libraries, frameworks, and tools for training and inference. On LLM inference alone, we have not only VLLM, but TRT-LLM and HGLang, as well as a myriad of proprietary frameworks. Finally, there is an explosion of models. Over 1 million models are now available on Hugging Face, over 3 times more since our last summit. So really, the story is simple. The huge changes in the compute needs for machine learning and AI workloads led to very rapid innovation in the infrastructure and tooling, which led to enormous complexity, which in turn led to huge obstacles to AI progress. I know everyone who is trying to build an AI platform knows this story by heart. We call this the AI complexity wall. You hire the best minds in AI, And they spend their days writing YAML files and troubleshooting Kubernetes. So the AI complexity wall leads to wasted resources, skyrocketing costs, and endless timelines to get to production. As Robert outlines, we originally created Ray to break this complexity wall. A complexity wall that is growing bigger and bigger every day. And over the last 8 years, we've had so many conversations with people in the growing Ray community about this complexity wall. And over again, what we've been hearing from you is that we need a unifying layer that sits between the bare metal and the exploding AI ecosystem. We need a software engine, you've told us, that can support any AI and machine learning workload, any data types and model architecture, decouples the allocation of different resource types, fully utilizes every accelerators, and scale from your laptop to thousands of GPUs. And do all this while being able to abstract away the complexity of this infrastructure from the end developer and serve as a flexible and unifying platform for the entire AI ecosystem. The rise of the AI era has made such an engine indispensable to the progress of AI. We are calling it an AI compute engine. An AI compute engine is critical technology for every company that wants to build a future-proof AI platform. The AI compute engine we are here to talk about today is, of course, Ray. Ray has become the AI compute engine of choice for the world's most experienced engineers who are trying to unlock AI in their companies. Now, I'd like to welcome Robert back on stage to walk us through the main elements of an AI compute engine, using Ray as our prime example.
All right, so I'm going to walk through a blueprint of this AI compute engine. And this is a picture we've formed from talking with hundreds of teams who are actually building AI platforms. OK, so I'll walk through the individual components that make up this engine. There are 3 core problems that the AI compute engine has to solve: managing compute resources, managing data, and executing workloads. So compute resource management, what is this? This is about managing the underlying diversity of cloud providers, hardware accelerators that Jan talked about. What kind of problems do you have to solve? Things like auto-scaling, selecting the right instance types, CPUs and GPUs, handling hardware failures, which are increasingly common at scale. Right? This goes very deep. Data management. Jan mentioned that AI is becoming increasingly data intensive, especially as multimodal models become commonplace. Right? So handling data effectively within this AI compute engine means handling large data. It means leveraging shared memory. It means optimizing data movement through frameworks, communication frameworks like NCCL and RDMA. Workload execution. This is the core scheduling and execution of the actual tasks that make up the AI workload. Scheduling has to be fault tolerant. It has to leverage accelerators. Right? It has to be highly flexible to be able to support the variety of AI workloads that are running on top. Otherwise, you'll end up with different engines for different workloads. Right, so within the core compute engine, you also have workload-specific optimizations for the most important AI workloads. And you have essential observability support, because people are going to spend all their time debugging and debugging performance. So this is the AI compute engine. And the entire compute engine powers the most important AI workloads that we see reoccurring across so many different companies, from data ingest and preprocessing to training to inference. But of course, for those of you building AI platforms, you know that the compute engine is not the whole picture. It sits within a vast ecosystem of tools. Now, without an AI compute engine, AI teams can suffer from serious fragmentation. Think different tech stacks for classical ML and generative AI. Think segregated pools of compute for different workloads, or complex development to production handoffs. or delays supporting new AI frameworks or models. So this AI compute engine is needed to rein in the growing complexity of AI. And that's why we're building Ray. Now, the result of adding an AI compute engine to your tech stack can be dramatic. After moving to Ray, Instacart is training on 100 times more data. Niantic reduced lines of code by 85%. And Canva cut cloud costs in half. These are just a few examples. You'll hear dozens more today and tomorrow. So with the AI compute engine blueprint laid out, I'd like to hand it back to Jan to share our first Ray announcement.
We have been building Ray for nearly a decade now. We started with the assumption that the innovation AI will be relentless. So we tried to design a platform that is flexible enough, that is general enough to easily handle constant advancement in AI. This year, we took a hard look at the rapid changes in the AI world and asked afresh, what is needed for Ray to remain the core AI platforms in every company? We talked to many of you about the top problems you are facing, about what challenges the next 5 years will bring. And based on what we learned from you, we have a number of significant announcements about how Ray continues to evolve. Let's start talking about performance, a necessity in a GPU-first world where models are getting larger and more complex. Consider the simple example of serving a large language model where the model is so big that in order to serve it, we need to split it across multiple GPUs. Now, while Ray is super flexible and general, the price it pays, it's a non-trivial overhead at runtime for tasks which are smaller than a few tenths of milliseconds. And this can be the case here when we generate a new token. Now, here is everything Ray does to generate a single token. Quite a lot. So let me dissect this for you. First, Ray needs to allocate the memory dynamically every time it passes an argument or a result between different nodes. Then, to transfer the data between GPUs on different nodes, Ray has first to copy the data from the GPU memory to CPU memory, a slow operation especially for large data items. Then it needs to transfer this data over standard slow network, and finally copy again data from the CPU memory to GPU memory, another slow copy. At the same time, the head node needs to pass the references to arguments and results via a bunch of remote procedure calls. So a lot of overhead to generate just one token. To reduce this overhead, we are introducing the first new major API in Ray over the last couple of years. It is called compiled graphs. This API is still experimental, so this is a preview. And we invite you, the community, to help us evolve it. Our goal here is to run tasks which takes less than 10 milliseconds with less than 1% overhead. So how do we do this? In a nutshell, compiled graphs is a static task graph with Ray-like API, which allocates resources once at the beginning and reuses resources across multiple executions. Going back to our examples, we created a static graph consisting of 2 actors, each actor handling a model partition. We compile this graph and then instantiate it. As a result, Ray pre-allocates all the resources and reuses them across multiple token generations. In particular, it pre-allocates static buffers for all arguments and results, so no need for dynamic memory allocation. Since we have pre-allocated all these buffers, there is also no longer need to pass around references to arguments and results. And finally, compile graphs set the peer-to-peer communication between GPUs and transfer data directly via NVIDIA Nickel, for instance. So no longer slow CPU to GPU memory copies or transfer over the slow network. So what does this mean for basic operation? Well, compile graphs are 17 times faster for GPU to GPU communication when GPUs are on the same node, 2 times faster when GPUs are on different nodes, and 13 times faster for scatter and gather operations on the same node. But what does this mean for practical AI and machine learning applications? We've actually been using compile graphs on both inference and training workloads, and we've seen some immediate benefits. For example, we use compile graphs to optimize LLM inference by adding both tensor and pipeline parallelism. By doing so, we increase the throughput for batch inference by 15%. This is already in production today. But that's not all. We also use compile graphs to optimize training for multimodal architectures. By collocating test encoders to cheaper GPUs, we increase throughput per dollar by 40%. All told, we believe compile graphs is a major step towards future-proofing Ray as a high-performance compute engine for the AI era, and we can't wait to see how the community is going to use it. And now, back to Robert for the next Ray announcement.
Thank you. All right. So if compiled graphs is Ray's answer to our new GPU-centric world, Ray data is the answer to the explosion of unstructured data that we're seeing. Unstructured data preprocessing is the single fastest growing use case of Ray that we've seen. You'll hear about it throughout this conference from Ford, ByteDance, many others. So what's special about these workloads? Well, unstructured data preprocessing and AI data preprocessing combines regular processing with inference. It requires CPU compute as well as GPU compute. And it's both GPU intensive and data intensive. So these are brand new systems requirements. Ray data handles everything from ingestion, ingesting the data in a streaming fashion, last mile preprocessing, and streaming the data into training. Many of you are already using Ray data in this fashion. I'm very excited for everyone else who's about to use it. If you're asking yourself, why do we need another big data processing system? The answer is very simple. Today's big data processing systems, like Spark, Flink, Hadoop, are CPU-based. And they work best when they're operating on structured tabular data. Okay? AI workloads are GPU-centric, and they often require unstructured data. So this is a brand new regime. Right? SQL is not going anywhere. Structured data is not going anywhere. But organizations are increasingly going to use AI to read their data, to reason about their data, and draw conclusions. And so data processing is fundamentally becoming an AI-driven and GPU-driven workload. Right? And today's CPU-based systems simply aren't going to work for those use cases. So we've tripled down on making Ray data excellent. I'm thrilled to announce today that Ray data is now generally available. Many of you are already using it, and I'm very excited for everyone else to try it out. Again, congratulations. Thank you so much. So like I said, SQL is not going anywhere. But we expect companies to see massive performance wins and benefits when switching to Ray data for unstructured and AI data processing. Just to give you a couple examples, Pinterest sped up batch GPU jobs by 4 times. They'll be talking in this conference. Instacart will talk about 5x cheaper batch AI processing. But most impressively, Amazon migrated an exabyte scale data processing workload from Spark to Ray. When they did that, they cut costs by 82%, saving $120 million every year. That's extraordinary. All right. Finally, I want to talk about stability. In terms of what actually matters, reliability at scale is at the very top, especially for many of us here, where AI is increasingly the key to our competitive differentiation, right? If that's the case, we need infrastructure we can rely on that's not going to introduce risk or introduce delays as we ship AI features faster and faster. So with that in mind, our team has been laser-focused on improving the core stability. We've quadrupled the number of nodes supported in a Ray cluster to 8,000. We now ship weekly Ray releases to get fixes and features in the hands of our users faster than ever before. And over the past year, our team fixed 1,700 different reliability and usability issues. This has been huge. The pace is only increasing, and we have massive plans for the rest of this year. So congratulations to the team. This has been a year of huge change at Anyscale. The biggest is that my co-founders, Jan, Philip, and myself, decided to bring on a new CEO to lead our next stage of building and growth. I'm very, very excited to introduce him to you today. Keerti Melkote is a builder. He built Aruba from zero to a massive customer-obsessed business. He's somebody who understands the true power of community and someone who joined Anyscale because of the incredible growth of the Ray community. So please welcome to the stage, Keerti.
Thanks, Robert. Stay with me. Hello, everyone. So excited to be here at this amazing event. Let me first start off with a huge thank you to Robert on behalf of all of you for starting the Ray project along with Jan and Philip, and for your incredible stewardship of the community. Thank you, Robert.
Thank you so much.
This community was one of the primary reasons why I joined Anyscale. The work you do and the impact you're making in this new world of AI is so inspiring to see that I simply had to be a part of it. My career, I've entirely focused on building infrastructure in each of the major technology waves, starting with the internet, followed by mobile, and then the cloud. In each wave, it took an entirely new generation of infrastructure to power it. And AI will be no different. AI infrastructure that can process massive amounts of data, train and tune models of all sizes, and serve them at scale is the need of the hour. And this is what motivates us at Anyscale. This opportunity to build infrastructure that empowers you to scale your AI applications is what motivates us. To do this well, we must commit ourselves to 3 key priorities. The first one is Ray itself. We need to continue to build Ray to be the most powerful AI compute engine in the industry. You just heard from Jan the release of compiled graphs, a major new update to Ray to enable GPU to GPU communications. You heard from Robert the general availability of Ray data and our commitment to keeping Ray the most stable, reliable, and performant AI compute engine in the industry, period. Priority 2 for us is this community, all of you. We need to continue to foster and grow this community, and we are today already 50,000 strong, which is an incredible feat. But we need to be 10 times the size if we are to meet the needs of this growing AI wave in front of us. And to do that, each one of you in this room is the key. It is very clear you've been super engaged in the community, helping each other. And I just wanted to name a few particularly prolific contributions over the last year. Teams at Intel, Amazon and AMD have added support for their accelerators. Google, Microsoft, Huawei, Ant Group, Workday, eBay, and ByteDance, and the list goes on. You've all made significant contributions to KubeRay, RayCore, RayServe, and the observability tooling. I just wanted to take a moment to recognize all your efforts and for your significant contributions. Thank you so much. Our third priority is we want Anyscale to be your partner to both de-risk and turbocharge your AI initiatives. In my first weeks here at Anyscale, as I met with a number of you, it became very clear to me that Ray is core to your work, and you want Anyscale to be an integral part of it. And it was also very clear that only a small handful of companies have the resources that it takes to build an AI platform around Ray as your compute engine. So to achieve this objective, we've built an enterprise-class managed Ray service that allows you to deliver a fully unified AI platform. Anyscale leaves all your data in your compute estate and adds a thin control plane on top that you as platform engineers and AI/ML practitioners can interface with to really get the best out of Ray. And to understand what we've added in Anyscale's managed Ray service, let's refer back to the blueprint that Robert talked about. So here's what's in Ray, and here's what we are adding in Anyscale. First, Anyscale brings together all your compute resources in a unified compute pool. Next, a truly optimized Ray runtime that is up to 6 times more performant than Ray open source. You'll hear a lot more about this shortly. Third, we've added an entire governance layer that every enterprise needs to maintain control over AI sprawl and runaway spending. And lastly, an end-to-end suite of developer tools and production services to create and build and scale AI applications. Next, we are going to hear about a number of major feature enhancements to the Anyscale platform designed to make Anyscale work for you and optimize your top workloads. To talk through these announcements, let me now welcome Anyscale's Head of Engineering, Jaikumar Ganesh, to the stage.
Thank you, Keerti. Excited to be here. How's everyone doing? All right, let's try something fun here. I would like everyone to stand up, stretch up your arms and legs. On a count of 3, 2, 1, we are going to say RayCore. Ray rocks, actually. 3, 2, 1. OK, let's do it again. Louder this time. 3, 2, 1. Great. You know what? I actually agree with all of you. Ray indeed rocks. Please take a seat. So Keerti talked about optimizing your top workloads. Robert earlier showed the AI compute engine. While Ray does abstract away a lot of the complexity of the underlying distributed compute infrastructure, it absolutely does not hide these away from you. This is not an overly simplified serverless solution. We have carefully taken knobs, levers, and pedals and exposed it to the serious drivers. This is a Formula 1 compute engine. We have taken this compute engine, worked with all of you to optimize your workloads. And today, we are excited to announce Anyscale's hyper-optimized version of Ray. We are calling it RayTurbo. To take a deeper look on how RayTurbo does on a data processing workload, I would like to invite Richard Liaw, co-creator of Ray and product manager at Anyscale, onto the stage.
Thanks, JK, for the introduction. Let's talk about RayTurbo. To start, RayTurbo is fast. We ran a workload comparing RayTurbo to open source Ray data. And this workload is really simple. Read some data from storage and iterate over it, similar to the data ingest phase of a distributed training workload. And what we did was we scaled the data set from 10 gigabytes to 1 terabyte, and we measured the time it takes for the first output to be returned. Now, compare it to open source Ray. The Anyscale RayTurbo implementation is able to perform up to 4.5 times faster. That's really, really fast. Now, RayTurbo is not only super fast, it also slashes your AI costs.
So batch inference for LLMs is a critical workload for all of you. So let's see how RayTurbo does on costs here. Here, we have taken an 8B model, run it on a data set of requests, 2,000 input and 100 output tokens with no shared prefixes. We compared Anyscale's RayTurbo with OpenAI GPT-4o mini batch pricing and Bedrock pricing. We noticed that RayTurbo is 2.2x cheaper than OpenAI and 2.9x cheaper than Bedrock batch pricing. Of course, in batch LLM inference, many times the same prompt is shared across multiple requests.
And in such situations, unlike OpenAI and AWS Bedrock, Anyscale can take advantage of prefix caching. As a result, we can see a much greater cost differential. On the same workload, if we assume a large shared prompt, we see that the Anyscale RayTurbo solution for this workload comes out to be 6.1 times cheaper than AWS Bedrock, even with its batch pricing. And here's the biggest kicker. These numbers were achieved without H100s or A100s. They were generated on widely available compute, namely L4s and L40s. This is going to be a huge game changer for LLM use cases across the board. Now, RayTurbo doesn't only slash costs, it also dramatically improves workload scaling. So in serving workloads, scale-up speeds matter a ton. To illustrate RayTurbo's capabilities in this situation, we compared open source KubeRay with Anyscale RayTurbo, and we measured the time it took to start up a 70 billion parameter model from scratch. Now, while the open source solution takes nearly 10 minutes, the Anyscale solution is able to scale up the replica in about 100 seconds, and less than 1 minute is spent to load the model itself. Together, that's a 5.1 times end-to-end improvement over the open source KubeRay and open source defaults. That's really, really impactful.
So we showed that RayTurbo is fast, and it makes your batch inference workloads and serving workloads scale up really quickly. All of these are impactful numbers that have an impact on your bottom line. But there are a lot more examples where RayTurbo really shines. So let's look at some of them. We saw that we can lower costs on spot instances for workloads like elastic training. We reduce the number of nodes required using techniques like replica compaction for your serving workloads. And we are seeing higher QPS with an optimized version of RayServe. All of this on RayTurbo, available exclusively to Anyscale customers. We also worked with all of you to improve the stability and reliability of the system. It kind of makes it a no-brainer to use Anyscale, the best place for using Ray and getting the power and benefits of Ray. Keerti talked about deploying in your environments and your work resources. To talk more about that, I would like to invite Dominic and Ife, infrastructure leads on Anyscale, onto the stage.
All right, JK mentioned F1, but let's take this analogy one step further. Winning in F1 comes down to 4 key factors: power, speed, efficiency, and control. We chose this metaphor for a reason, because if you are an AI platform leader, you're typically balancing between these attributes for yourselves and for your teams. What do I mean? Power. You need to put all the horsepower you have behind your developers. Speed. You need your developers to drive fast. The race for AI is happening at breakneck speeds, and you must remove all roadblocks. Efficiency. You want to take full advantage of every resource that's available, firing on all cylinders, but not burning through the gas. And finally, control. You need to give your developers guardrails, because these cars are insanely fast and very pricey. We're going to dive into each one of these.
Let's start with power. At Anyscale, we have been building a turbocharged engine aimed at getting the most out of cloud machines on AWS and GCP. However, the last years have shown while the clouds are powerful, they are not unlimited. Many of us here are very familiar with this error message. Yes, cloud might have capacity issues, and clouds are certainly not cheap. We've seen companies of every size rethink their cloud strategy, many of which decide to go invest back in on-prem specialized machines. What if we could take the power of these on-prem machines and make them available to our scientists and engineers, just like the clouds? So with this vision in mind, we have built the Anyscale Machine Pool. Machine Pool makes it easy to create hybrid Ray cluster that span both the cloud and on-premises, taking any machines in the world to amp up what's available in the cloud. And of course, you get all the optimization of RayTurbo, JK and Richard just talked about, out of the box. And there you go, power.
Machine Pools takes our VM offering and shifts it into overdrive, but it doesn't unlock compute for everyone. We know that the developers and companies pushing the boundaries of AI on Ray, you all here today, have largely been deploying on top of Kubernetes with Kubray, by far the most common pattern we see. So this year, we thought to ourselves, how do we take Anyscale, our platform, our optimized Ray, and deliver it to you on top of your Kubernetes clusters? In that vein, we're thrilled to announce the Anyscale operator for Kubernetes. The Anyscale operator lets you supercharge Ray on your Kubernetes clusters, letting Anyscale deal with the heavy lifting of configurations, dependencies, and security of Ray. The Anyscale operator was designed to be highly customizable, meaning Anyscale can be a part of your existing AI platform. But we're not doing this alone. We're thrilled to announce our launch partners for the Anyscale operator for Kubernetes. So whether you're on Amazon EKS, taking advantage of Trainium and Inferentia, whether you're on Google GKE, leveraging their TPUs, on Azure AKS, or even Oracle Cloud Infrastructure, we can work together to bring the best of Anyscale, Ray, and these providers to you. So thank you very much for our launch partners. There's much, much more to come. So to make this super clear, whether you're running on cloud-native VMs, on-premises, or on Kubernetes, Anyscale can turbocharge your Ray clusters anywhere in the world.
Now let's switch gears and talk about speed. I'm sure many of us here have stepped through the pain of waiting 5, 10, 20, even 30 minutes for a large cluster to spin up, and then having the realization we need to do this over again just to try a different GPU type. I know this entire process is very slow, it's very frustrating. It does nothing but holding us back. So to solve this problem, we have built the Advanced Instance Manager, capable of launching massive Ray cluster extremely fast. We're talking launching thousands of nodes in under just a minute. It also scales up faster than open source Ray, speeding up your iteration cycle so you don't have to spin your wheels. So to take this a step further, we're also introducing the automatic worker node selection feature. This is a feature that allows you to specify your resource requirements, like your accelerate type, directly in your Ray code instead of in a separate configuration file. And then it will automatically choose the most cost-effective instance type for you. Overall, the Advanced Instance Manager lets you focus on your AI application instead of wasting your precious time thinking about the underlying machines. So, saving time, saving money, going fast.
Let's turn to efficiency. The cost of AI is real. Being able to launch clusters quickly and reliably on the most cost-efficient infrastructure saves time, money, and your developer sanity. Which is why we built the Advanced Instance Manager to be aware of every region and availability zone. We're able to maximize availability while also optimizing for spot utilization. With a single flag, one flag, we can scan an entire region for spot capacity before looking for on-demand. And when spot becomes available again, we can seamlessly migrate your workload back to spot. So, as capacity changes, as your workload scales, Anyscale is consistently landing your AI applications on the most cost-efficient infrastructure. Lastly, control. Backing all of this is the Anyscale Governance Suite. The Anyscale Governance Suite gives you everything you need: resource quota management, budgets, visibility, telemetry, everything you need to stay friends with legal and finance. Very important. But seriously, we want every team to become an AI team, and the Anyscale Governance Suite has you covered. So to recap, today we are launching features that gives you the full power of all of your resources in your compute estate, on cloud, on-prem, and on Kubernetes. We're releasing radical speed and efficiency so your engineers can rapidly unlock the full potential of this estate. And finally, the fine-grained control you need to maintain your sanity as a platform leader. Because yeah, these cars, insanely nice. Now, to take us through the life of a developer on Anyscale, let's please welcome to the stage Goku and Angelina.
So, Goku, I know you have that flight to catch tonight for your honeymoon.
Yeah.
You know that image identification application you started to build?
Yes.
You're going to need to finish that before you go.
Right before my honeymoon? All right. Well, I started developing on this Anyscale workspace here, and you've literally caught me right in the middle of total dependency hell. I have no idea what compute my workloads need, and I don't even know how to get started with debugging any of my workloads. I'm totally screwed.
Relax, breathe. Walk me through these one by one.
OK, well, for one, I forgot to install a really important dependency, and now I have to go through each of my workers one by one, and who knows how many other dependencies I forgot. I'm going to have to make a phone call and probably catch a later flight now.
Hold on. Isn't that why we bought Anyscale? Just do the pip install on the console, and now your head node and all your workers that you might spin up later on will automatically have your dependencies ready to go.
Whoa, OK, that's really cool. And I feel like this is going to save me a ton of time. But I feel as like a developer, I know how to make things, like these workloads, but I have no idea what compute I need. I just don't even know where to get started with this.
Don't worry about it. We toggled the auto-select worker nodes, so Anyscale will spin up the right number of workers, execute the workload, and spin them back down when they're done.
OK, that is really cool. And I feel like this is going to save us a ton of time and money, hopefully money that can be applied towards my next bonus.
Not.
OK, worth a shot. All right, more workers sounds great, but I feel like with more workers, doesn't that also mean more problems? I mean, what if I experience an error here? How am I going to know where to look and debug? That's going to take me forever. Let me actually make that phone call and probably cancel the whole trip right now.
Stop panicking. We just need to check out the unified log viewer. on the Logs tab. This page consolidates the logs for all the workers and other distributed components. That means we can find the exact root cause error right away.
OK, I love this. But I feel like my wife is going to love this unified log viewer even more than me. I mean, so much more time back in my life. All right, I think we're pretty good here. I'm able to ingest a little over 20,000 images, and they're getting embedded in index now. So am I good to go? Can I head out?
Oh, one more thing. Let's get this up and running for online inference.
Online inference? You mean production?
Of course.
No, that's actually going to take me forever. I need to rewrite all of this from development over to production, not to mention actually getting this up and running as a service that can scale up and down. It's just not going to happen today. So let me actually make that phone call now, and probably to a divorce lawyer at this point.
Stop being dramatic. A single line to launch all of this as a service, and we're done.
OK, I'm actually going to name this Anyscale Save My Marriage. And wow, OK, this is awesome. In literally 3 minutes, Anyscale helped me get out of my total dependency hell, helped me find the optimal compute I need. We're debugging on top of literally thousands of workers all in one view, and now it looks like we're rolling out to production. And it looks like it's spinning up. I'm actually going to head out now, so I'll catch you later.
Woohoo! Have a good one. Whew! Looks like Anyscale saved a marriage.
Wait. I'm sorry. My flight was actually delayed, and it looks like I have a lot more time now. So I'm just going to relax here for a little bit and
Sure.
Yeah, take my time.
Great. Well, while you're here,
yeah.
let me tell you about the project you'll be working on after you get back from your
All right,
honeymoon.
let's hear it.
It's an LLM workload with very large data and models.
No. Our platform is made for classical machine learning, and we just got it running for deep learning use cases. LLMs are a completely different story. There's no way this is going to work. I mean, for starters, for fine-tuning these models, where are we going to get the compute? We can't even find anything. And then serving these models in an efficient way, not possible. If this is what I'm coming back to, I might just stay on my honeymoon forever.
Enough with the hyperbole. Look, Anyscale has a new LLM suite specifically for this.
OK, let's see how comprehensive this is. What models can I use? Can I use whatever I want?
We can use any model on Hugging Face.
OK, what about different fine-tuning tasks, like for classification or instruction tuning or preference tuning?
Yes, to all those, including distillation.
OK, but what about actually doing the fine-tuning, though? I feel it's so hard to find A100s or H100s these days, and these models just keep getting bigger.
Don't worry about it. We can train on smaller, more available hardware like A10s, and Anyscale takes care of all the distributed work for us.
OK. What about serving, though? Can I serve thousands of small LoRa adapters on top of the same base model?
And optimize for latency or throughput.
OK. All right, this sounds really cool. What do I have to install? A bunch of new stuff for this, or?
Absolutely nothing. It's the same Anyscale platform we used before.
OK, this actually sounds like a ton of fun, so I may just get started on this right now. OK.
Oh, no, you don't. Go.
Are you sure?
Check your flight.
All right.
Yes.
Oh, my work laptop.
And don't forget your work laptop.
Thank you. See ya.
Wasn't that fun? Goku, go enjoy your honeymoon, and don't forget to send us some photos. All right, so let's recap all the announcements. We introduced RayTurbo, which makes your workloads go faster and cheaper. We talked about Anyscale machine pools and Anyscale support for Kubernetes, which lets you deploy your workloads in your environment using your resources. We showed how ML application development can be effortless with features like automatic worker nodes and advanced instance manager. Anyscale Governance Suite will make your finance team smile. And finally, and most importantly, we showed that we can do all of this without compromising on end-to-end developer experience so that Goku can enjoy his honeymoon. I'm so excited to see what you all will build. I feel like going, developers, 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 but I'll keep the chant for some other day. So with that, I would like to welcome back Keerti on stage.
Thanks, JK and team. so exciting to see all that amazing work, building out Ray as the premier AI compute engine and Anyscale as a unified AI platform. We can't wait for you guys to try some of these exciting new features out. But so much of the power of the story is about the ecosystem. Ray and Anyscale are a platform, and for a platform to work, it needs incredible partnerships. At the technology level, this means connectors to Databricks and Snowflake. It means integrations with MLOps tools like weights and biases and MLflow, orchestration platforms like Airflow, DevOps tools like Datadog, and many more. Anyscale integrates with the entire AI ML ecosystem, and we invite new partnerships. Please let me know if you're interested in partnering with us. I'm also glad to announce that Anyscale is now available through the AWS and GCP marketplaces. And we are also very excited about having every major cloud as a launch partner for our Anyscale operator for Kubernetes. And on this note, and so importantly, an elevated thank you to all our sponsors. Thank you to our platinum sponsors and the many other sponsors that you see on the screen. We would not have been able to host this Ray Summit without you, so thank you very much. We really appreciate it. I'm so excited to hear later today from Anastassis and Marc Andreessen, tomorrow from Brandon Leonardo from Instacart, and the almost 200 speakers over the next 2 days. Our team is available at the Anyscale booth in the expo hall to take your questions, give you a test run of all the new features that you heard about today, and provide guidance to all of you as you explore your AI workloads. Don't hesitate to reach out to me directly if you want to talk through your AI journeys with me. Finally, I'd like to close by saying how inspiring it's been getting to know this community and all the amazing work that you do. There's just so much energy here. Ray has truly become the premier AI compute engine for the industry, and we have added many new capabilities in Anyscale to make it truly enterprise ready, and I encourage all of you to look deeply into using it to supercharge your AI efforts. Most importantly, what you're building has huge potential to genuinely change the way we live. So thank you very much for building with Ray. Next up, I'd like to invite a customer, Anastassis Germanidis, who is the co-founder and CTO of Runway, a leader in generative media and storytelling. I'm sure you'll be super excited to go through all of his amazing videos that they've created on their platform. Welcome, Anastassis.
Some really exciting updates today. So I'm going to talk about some of the work that we've been doing at Runway over the past year. For those who don't know, Runway, we build creative tools. We're an applied research company that works in the intersection of art and technology and focuses a lot on kind of the next generation of generative media tools. I always like to start my presentations by kind of doing a brief history just to contextualize the current moment that we're in. I think it's easy as, given the pace at which, the field is moving, to forget how quickly things have evolved and how much progress we've made in such a short period of time. So this is what generative video looked like in 2020. This was the first kind of generative video feature that we released before kind of generative models were kind of all over the place. It allowed you to, it took an image model, a generative adversarial network, which was the popular kind of architecture at the time, and interpolated between different kind of points in the latent space. It was decent at generating, at being able to train a model on just one specific type of object, like shoes or faces, but it could barely generalize. And even at this very specific domain, it wasn't kind of that photorealistic. Moving on, we go to 2021. And this was our first internal attempt to make a short film using generative models. It's a film kind of internally that we call the Orange, and it was using a kind of interactive segmentation to translation model. So as you can see, it wasn't quite it was very pixelated. It's very low frame rate. We had to create each frame one by one. You could tell a story, but maybe not a very compelling one. And now we're moving on to 2022. And progress in image generation is moving fast. And while you don't have a very coherent kind of long video, you start to have at least the first frame being getting close to photorealism and getting close to kind of something compelling. And then we move on to 2023. That's when we released our first kind of generative video models, Gen 1 and Gen 2. And these are some clips from our Gen 2 model. So you can see you're now starting to get this signs of motion. You can see animals moving. You can see kind of the waterfall flowing. But the scenes are still fairly static. You don't see much change in the scenes. And finally, at 2024, we released Gen 3 Alpha. And you can see, I think the leap in quality and photorealism should be obvious, but more so the leap in the ability to generate coherent motion. You can see that the scene can change over time, things that really weren't present before. So the goal of this brief history is to just show, create that exercise of extrapolating where we're going to be a few years from now if that pace of progress continues. The way we think about video generation is as a kind of world modeling. That's the framework we've been taking as we continue to scale those models. In order for those models to predict video, to be able to generate coherent video that looks like real-world video, it needs to learn different concepts about the world. It needs to learn both the semantics and the visual composition of scenes, but it also needs to learn 3D consistency. It needs to move in a scene in a way where objects maintain their place. It needs to handle occlusions. So there's all these aspects that the model is not explicitly trained to learn. It learns those aspects of the visual world by just this simple task of predicting the video. Kind of similar to in the language domain, how we predict the next token, predicting the next frame gives rise to all those amazing capabilities. And while the scaling laws on the language domain have been, at this point, fairly established and adopted by the field, it took a longer time for the same kind of framework to be adopted in the image and video domain. But it really, we see the same thing in the image and video domain as we saw in the language domain. We saw that as you put more compute and data into these models, they're able to consistently and predictably improve in performance and improve in the ability to generate kind of photorealistic, really well-aligned to a text prompt. And we expect that to continue. I think we're close to saturating the improvements from scaling those models. And we see that as a very viable path towards building more and more capable general world models. So I want to showcase some of the emerging capabilities that we've seen with Gen 3 Alpha. Again, those are not explicit tasks that we train the model with. Those are things that the model kind of learn on its own. One of the most surprising and interesting aspects of Gen 3 Alpha is the ability to really introduce changes in the scene that weren't over the duration of the video. So this was something that the previous generation models really struggled with. It might be able to generate, continue the motion from the first frame, but it wasn't really able to introduce new elements on the scene. And this is something that if you want to tell a narrative that where things happen, you want to be able to do that. It's much better at photorealism specifically for humans. Obviously, generating human characters that are able to do a wide range of motions and actions in the world is a very important part of doing any kind of storytelling. And we saw with Gen 3 Alpha this really, really amazing emerging capabilities and the ability for humans not just to display coherent motion, but also to interact with objects and have the state of the objects change in response to that. So here you can see as the person is playing the piano keys respond to that interaction, which is, it might seem an obvious thing, but it's something that the model had to learn about how different elements in the scene will interact with one another and how different actions that you take change the state of the world. We also saw a really amazing improvement in the ability to generate text. And this is something that, again, it's a bit different than what we see on the image domain, where you might be able to render photorealistic text. But here you can see that the text might appear in the middle of the scene, and you have this really ability to create these amazing titles and animated content out of it. And what I'm really excited about is this ability to really understand in a deeper way the interactions that happen in the world. It's not perfect. It doesn't follow the laws of gravity perfectly. It has an intuitive understanding of physics, just like humans do. But compared to the previous generation of models, it's quite a big leap. And similarly, the ability to simulate liquid quite coherently is something that, again, was not explicitly taught in the model, and it's able to kind of learn that from data, which is really remarkable. One of the big focus points at Runway is the ability to control the outputs of the models. We're not just interested in research for the sake of research, in having really compelling outputs from the model, but outputs that reflect the desires, the vision, the ideas of the artists and the creators that use our platform. And so a big focus for us has been this idea of multimodal control, of being able not just to control the outputs that you want to generate by text, but also by starting image, by conditioning on an input video. And all those modalities have different use cases. And the general way we think about it is that we want to maximize the number of choices that artists can make in the course of using those tools. And this is a bit different than the traditional perspective around those AI models, which is kind of minimize the choices in some ways to allow the model to kind of take actions on its own. Because ultimately, making art, telling stories, it's really, we see it as a reflection of kind of the human that's creating those stories and the reflection. And rather than trying to kind of automate that process, we just want to augment the artists that are using the platform. So another way to think about it is, there's a lot of talks about agents, about this ability to kind of independently take kind of multi-step actions in the world, or to do kind of complicated multi-step reasoning. But we see the models as more thought partners, where we want to maximize actually the input and the ability to tell unique stories by human users, rather than tell a story that's compelling. Because I think that's ultimately where I believe the real promise of generative media exists, in this ability to maximize and kind of increase the number of stories that are told, and kind of we say internally, the best stories have not been told yet, the best movies have not been made. And I believe that in order to really tell those stories, you need to be able to feel like the tool is part of you. It's not something that's kind of independently working in the world. So it's a different perspective than the kind of more common approach that's being taken these days with those generative models. But I do think it's a much more promising way of actually making those models usable and useful for people. Just to showcase some of the work that we've been doing on controllability, like I want to highlight 2 different control modes that we've introduced in the past few months. This is the image to video mode, and it allows you to, given a starting frame, which in this case, it's kind of photos from in different places in New York, you can introduce elements in the scene. And what I'm really excited about is, again, this idea that you can really, really kind of introduce really dramatic change in the scene. You can open portals to other dimensions. You can, and this is not what traditional image to video was able to do. And so we've seen really amazing work being done with our image to video tool. And similarly, we've seen really amazing work done with video to video tool. So video to video allows you to take an input video, which might be something you shoot with your camera, and then maintain the structure, the overall structure of the video, but completely transform the style. So in this case, you have actually a video that's taken with a Vision Pro from our office in New York. And you can see how you can kind of completely transform it. And the use cases for that are so vast, like the ability to, like I like to call it the actually augmented reality. This is, you can really create an extremely compelling, transform completely like what you're seeing in real time. A lot of engineering challenges went into training Gen 3 Alpha. There is, at this point, more established practices on the language domain and training and scaling language models, but there is some unique challenges around training video models. The most obvious one is that each sample, the size of each sample is orders of magnitude greater than the size of a sample that goes into language model training. And that introduces a lot of bottlenecks on the data loading side, on making sure that that network does not become a bottleneck, and yet that you're able to handle communication overlap well. A lot of challenges specifically go to data preprocessing, on ensuring that your data set that you're training on contains the tasks that you want the model to learn. And it also contains, balances quality, balances diversity of content, of styles. There's so many dimensions quality and that you need to think through, and making sure that you curate the data set well. And in order to tackle those data preprocessing challenges, we looked around, and we really restructured our data infrastructure and data pipeline. And this is where Ray was crucial, and the work that the Anyscale team has been doing has been really fantastic at enabling us to really move fast and perform the data preprocessing, that large-scale data preprocessing on time. We solved challenges for the first time, where we scale to tens of thousands of instances to do our data preprocessing work, and the Anyscale team was really there, and an extension of our team to help us through those challenges. And Ray really starts from a principle of getting the developer experience right, and then building everything else on top of that. And I think that's the right mindset to take, especially on a field that's moving as fast as this field, where the patterns of communication, the kind of workloads that you want to run, change so quickly with every model scale, with every next generation models or new modality that you're introducing. There is new unique challenges to that. And Ray allows you to really iterate much faster, to run things very easily locally, and then scale them to large-scale workloads much faster than other frameworks that we tried. And so we're really happy with our collaboration so far with the Anyscale team. I want to talk a bit about what's next. Again, I want to go back into this idea of world modeling, and this idea that understanding the visual world is really fundamental to building building generally useful systems with generative models. I think it's an underlooked aspect of intelligence. I think there is perhaps too much focus on the language domain and achieving general intelligence through language. But there is so many aspects of the world that are not actually properly captured in language. And language is a very lossy compression of reality. So there is a lot of room to take this idea of world modeling from visual data further. And visual data could be, could be extremely multi-scale. You can describe anything from kind of angstrom scale, kind of interactions, to really kind of describe kind of astrophysics data that's also expressed in kind of video form. And so that's what's coming next for us, is this kind of expansion of the vision of world models to be able to achieve more, build more universal simulations of reality. And the applications for that, I think, are vast. They go beyond content creation. They go towards a wide variety of use cases that I'm really excited about. You might wonder, like, what's the connection between this idea of world modeling, this idea of understanding the world to a greater extent than before, with the kind of artistic focus of our team, which is at the core of what we do at Runway. And I think they're actually very much related. The more you can model reality, the more you can build a very accurate distribution of the world, the more you can actually go out of distribution. And you're seeing with that with a lot of the videos that come out of Gen 3 Alpha. They're videos that don't look like any videos that have ever been made before, because those models learn the constituent aspects of the data they're trained on, and they can combine and remix and put concepts together that have never been put together before. And the only way to achieve that is to actually for the models to learn those concepts well. So I believe that as we build more and more capable world models, we're also going to be able to make art that's even more unique and even more out of distribution than before. Nothing that we do at Runway matters if, like, without the community of artists and creators that use Runway every day. I think it's really important for us to push the field of generative media forward. And there is, at this point, not as many opportunities for the creators that are using those, that are experimenting with those models, that are really kind of discovering what AI filmmaking is about. And so a lot of our effort at Runway has been spent on kind of building that community, on finding ways to showcase all the great work that's been done by the kind of artists that are taking a chance on those models, on this technology. We've been hosting this AI film festival for the past 2 years. We hope to continue it, which showcases short films that use AI in one way or another. And we've seen really amazing stories come out of that festival. We've seen people start entire careers from the festival, where before, this was something they were experimenting with part-time, and now for the first time, after showcasing their film, they're now able to kind of build a career out of making those films. More recently, we announced the 100 Film Fund, and this is yet another opportunity to sponsor and support artists that are making compelling stories with generative media. This is a fund that supports specific AI film projects that use AI in one form or another. And we're very excited to see what stories are created once those artists and creators have the space and the time to actually work with those tools and make compelling stories with those tools. So I think the next year we're going to see AI filmmaking. As the models improve, AI filmmaking will expand even further. And we're going to see so many new stories being told that have never been told before. And I could not be more excited about that. Thank you.
Thank you so much. Thank you so much. Every time I see these videos, my mind is just blown. They're floored. The work that Runway is doing, I think it gives us a taste of where AI is headed, some of the capabilities that are coming just around the corner. And what I love about Runway is not only are they pushing the field forward, but I think they also inspire the rest of us to think bigger. Next, we're very fortunate to hear from one of the most influential people in technology, Marc Andreessen. Marc is a co-founder and general partner at Andreessen Horowitz. He has built multiple billion-dollar businesses, from creating the Mosaic internet browser and co-founding Netscape, to co-founding LoudCloud, which became Opsware. His track record speaks for itself. I'm thrilled to have him here to share his insights. Please join me in welcoming Marc. Hey, folks. Thank you so much, Marc. Pleasure to have you here.
Good.
So let's dive right into it. You've seen many of the big technological shifts over the past decades, right? From the internet, mobile, social media, the cloud. Can you place AI in the context of these waves?
Yeah, so this is a big one. This is a really big one. So there's this great book I'll recommend right off the bat called Rise in the Machines by Thomas Rid. And he goes back and he reconstructs the very beginning of the computer industry, the sort of computer revolution back in the 1930s, 1940s. And it turns out back in the 30s and 40s, they actually had a big argument at that time of whether computers should be built the way that we understand them today, which is what so-called von Neumann machines. Basically very fast, calculating machines, that are very good at doing math at high speed, but aren't very good at kind of dealing with people or dealing with the real world, or whether computers should be built basically modeled on the human brain. And they actually had enough neuroscience at that time where they understood the basic neuron structure of the brain. The first paper on neural networks actually came out in 1943, 81 years ago now. And there were, figures like, Alan Turing and John von Neumann and others, who argued, that basically that would be a superior architecture. And then basically what happened was, right, the computer industry kind of forked, and 99% of it, was dedicated to building out computers the way that we've had them for the last 80 years. And then there was always this kind of rump, academic movement, which was for to kind of build out neural networks. And that proceeded decade after decade after decade. And frankly, if you talk to people in that field, there wasn't much to show for it for a very long time.
It takes a lot of conviction to really persist there.
So there were people would get their PhDs in artificial intelligence. They would be born, they would get their PhDs, they would spend their entire careers researching it, and they would die before the field worked, right? So this is like a high level commitment. When I was in college in the late 80s, there had been actually an AI sort of boom bust cycle. In the 80s around so-called expert systems. The people thought we were very close to like automated medical diagnosis, all these things. And it didn't work. The technology wasn't ready yet. And so by the time I got to college in 89, the field had been discredited. And so you would meet these, sort of sad figures, who were sort of toiling away, kind of wasting their lives. And then of course it turns out they were right. But it took us, and how long did it take to figure out they were right? Really, it took probably 70 years to figure out they were right, because they started, turning out to be really right starting in around 2012, 2013, which is when the famous ImageNet test happened, and then it sort of proved that computers could recognize objects and images better than people. And then that led to the creation of the self-driving car, which is now really working really well. And then that led to what became increasingly good voice recognition, voice synthesis, in the mid 2010s, and then the Transformer paper in 2017, and then obviously ChatGPT and Midjourney and Runway and all these things, and here we are. And so the way I think about this is like an overnight revolution that's been 80 years in the making, right? And so it turns out it's incredible, because it turns out we have this incredibly rich, kind of history of 80 years of ideas now that turn out to work, that are now going to get used in all kinds of ways.
Well, how do you see it unfolding now? Is the internet a good analogy if we're trying to look around the corner?
Yes, I think it's more just I think the internet is not actually as good of an analogy, because the internet was sort of taking existing computers and using them to kind of stitch together networks. I think this analogy is probably more to the microprocessor or to the computer itself. So the way at our firm, the way that we think about AI systems is they're new kinds of computers. And the way we describe it is kind of traditional computers are so-called deterministic computers, which is they give you the same answer every time. They're kind of very they're very literal in what they do. And if they ever if you ever give them the same input twice and you get two different results, it's because something has gone very badly wrong, and it's probably your fault as the programmer. AI systems, we view them as computers also, but probabilistic computers. You give them the same input twice, they give you 2 different outputs, which is amazing, for those of us taught, it's kind of the old model. And then they do this incredible, kind of thing, which is, they have different terms, but, they hallucinate, right? They like, people describe to me, it's like, AI skeptics will say things like, well, AI, is not useful because like when it doesn't know the answer, it just makes something up. And I'm like, well, have you met people? That's precisely what my 9-year-old does. Very interesting, right? And then, as we just saw with Runways, with these spectacular videos, there's this like fine line between hallucination and creation. So we have literally computers now that can create.
So it could be a feature or
can actually create art. And so we basically have sort of another bite of the apple, right? The sort of magic apple. We have all the traditional computers, and now we have this new kind of computer, and then we have this, and then of course a big part of the story is the massive payoff, right? Why does AI work today? Part of it is the experts kind of got the algorithms to be really good, but a big part of it is Moore's law actually provided the compute power, and it just turns out, right? You just need a lot of compute power. And then the internet provided all the data.
Yes.
Right. And so why do computers do a better job now? AI does a better job recognizing cats in photos. It's because the internet is filled of photos of cats.
Yeah, we take these scaling laws for granted now.
Yes.
But that was not obvious.
You could not. 20 years ago, 30 years ago when I was in school, like even if you had the right algorithms, you could have never made these systems work. And all of a sudden now they work. And of course now the pace of change is just absolutely extraordinary. I mean, I see things every week now that just put my jaw on the floor. So I think we're in for years of just incredible creativity.
I mean, you have a unique vantage point at A16Z, seeing many different industries, right? I'd be curious what you think about the impact that AI is going to have in a variety of different domains, whichever ones you want to talk about, but I'd be curious about AI in biotech or AI in finance or AI in defense.
Yeah, so a couple things. So one is that we think it's going to be transformative in actually every single one of those sectors, and we're investing across all of those. And we can talk about each of those. So I think it's going to be a really big deal in all of those. I think there's a really good chance that it really reinvents almost every product category that we think we understand today. And again, just take Runway as an example. Like, are people in the future really going to be doing video editing or photo editing, like using like Photoshop or Final Cut Pro or these things, or are they going to? Or are you going to be talking to the computer and the computer does the image generation editing? And so I think there's these huge industries where people kind of assume things work a certain way where they're going to work very different. And of course that means it's going to be prime time for startups, right? That have the huge advantage of being able to to start from scratch. So yeah, no, we think this is going to be a really big deal. In the tech industry, this classic dynamic is playing out where every incumbent tech company is adding AI to their product, right? And then we have startups starting in every conceivable category from scratch. The metaphor that we use to kind of justify, because we go to our investors and say we're going to invest in all these AI startups, what we say is like, look, like if you have an existing product and you add AI to it, it's a little bit like adding flour into a cake. Like after the cake's already been baked, like it doesn't work well. If there's a really transformative technology, you have to get the flour into the recipe from the very beginning. You have to build from scratch, knowing you have the new capability. And by the way, there's a bunch of companies. The sort of later stage startups are like halfway in the middle. We have this phenomenon we call bullet point number 6. Or we'll get a sort of a 5-year-old company or whatever will come in and pitch, and they'll have their product slide, and it'll have the 5 kind of things their product does. Then it'll have bullet point number 6 is, oh, it also does AI, right? And it's always bullet point number 6 because of course they added it after the fact, right? They couldn't quite, the smart ones go in and redo the slide. And so there's a lot of adaptation happening now. Look. In the mobile to web, in the web to mobile wave, a lot of the big actually incumbent companies like Google and Facebook actually did just fine, right? And so it certainly may be the case that a bunch of incumbent companies actually adapted this just fine. I think it's going to be challenging. It's going to be a lot of work to do that because this is such a different way of operating. I tend to think that startups have a really great run here, but it's going to be a real fight, kind of in the industry, and we'll see.
Yeah. You pay a lot of attention to biotech,
yeah.
Right? What does this look like? I understand it for software products, but what do you think the role of AI will be in biology?
Yeah, so look, so the big thing in biotech biology is sort of that we've always had this concept of sort of drug discovery, which is this kind of amazing term, and basically, the way that sort of the modern world of kind of drugs treatments, has emerged is you sort of have, basically a lot of scientists basically trying lots of different compounds and kind of seeing what works. So you're literally kind of discovering what works. The sort of overall giant transition that field wants to go through is to go from discovery to engineering, right? So where you're actually designing things from scratch, including literally designing new drugs from scratch. And we're starting to see examples of that. The mRNA platform that was the basis of the COVID vaccine, is a good example of that. Moderna had it was a very interesting. Moderna and Pfizer are the two companies that had the first COVID vaccines with similar technology. Moderna had the first COVID vaccine 2 days after they were emailed the genome of the COVID virus from China, like in a Word document, which is first of all like a fairly amazing thing because it's like spell check is pretty aggressive in Microsoft Word, and like you certainly hope that it didn't screw things up, but it turns out it didn't. It was fine. But then literally they had that vaccine 2 days. They had the COVID vaccine in January of 2020, and then the rest of it was just testing and validation. And that was the consequence of mRNA being an agile engineering platform for biotech. And so the minute you have an engineering platform, you can bring AI to bear.
Do you think we have enough data in biology today?
So it's a real challenge. It's a real challenge, and I would say it's a real challenge in particular because access, what you really want, like if you wanted the perfect biotech industry, what you would want is you would want to basically get everybody's health data, pool it all together. You'd want to get everybody's genome data, pool it all together. That in the U.S. that would all be completely illegal. You would never be allowed to do that. You would go straight to jail. Interestingly, in China, that's actually just fine. So it is actually this very interesting opportunity for societies like China to maybe leapfrog us on that point. So yeah, there are big challenges on that, but the payoff is also going to be very big, and so I think there's going to be a lot of positive pressure to figure out at least how to get enough data to be able to do the work.
Yeah. Speaking of China, how do you think AI will shape geopolitics or defense or some of these spaces?
Yeah. So this is an area where actually the sort of theoreticians in defense were actually ahead. They were on this several years back. So right around the mid-2010s, there was actually a sort of major change of military doctrine in both the U.S. and China. So in the U.S., the Department of Defense has a thing called offsets, and it basically an offset is like a new technology that will fundamentally change how wars are fought. And they declared that AI and autonomy in combination were what they call the third offset. And it's a big deal because the first offset was nuclear weapons, the second offset was what they call maneuver warfare, and then the third offset is AI. And then China similarly has been very public.
And actually, what is maneuver warfare?
Maneuver warfare is sort of like small unit tactics, precision-guided weapons, sort of specific applications of force as compared to just launch the nukes or launch the bombers. And so maneuver warfare was like a consequence of advances in communication technology. GPS was a big part of maneuver warfare. But AI is the big one, and so anyway, so the U.S. kind of forecasted that, and the Defense Department, and look, we have the Predator, we have the Predator drones, that have that fly autonomously that have played a big role in counterterrorism. So that started to happen about a decade ago, and then China similarly embarked on a major, and they've been very public about this, kind of a major rebuild of all of their systems, based on AI.
A decade ago is pretty early for this shift, given that the excitement around AI now. What triggered that?
Oh, I think it was basically they started. Well, one is they self-driving cars started to work. The original DARPA Grand Challenge for self-driving cars was in 2005, and then so you started to see those basic systems started to work, and then you started, obviously autopilots on airplanes started to get really good, and they started thinking about taking the pilot out of the airplane. And if you take the pilot out of the airplane, all of a sudden you can build very different kinds of aircraft that maybe are much more maneuverable, much faster, because they don't need to keep a pilot alive. And so these kinds of things, and then they keep people safe, right? And so those changes started. And then of course what's really accelerated all this thinking in the national security world is specifically the battlefield in Ukraine. Where it's like this, and start by saying it's an incredible tragedy that this is even happening. But what's happening on the Ukrainian battlefield is shaping a lot of thinking around national security.
What is happening?
What is happening? Well, it's like 20th century versus 21st century. It's like a cyberpunk movie. It's fairly amazing. Which is the Red Army, the Russian military basically is driving tanks down. And the Ukrainians are responding with, first-person, basically literally professional video game players piloting in VR, piloting autonomous drones, and then coming in on top of the plane and blowing up and cooking it on the inside, or these shoulder-mounted weapons like javelins that again are kind of they call them fly-by-wire. They sense where the thing is. So there's a tank and you have a javelin, you sort of wave the javelin in the direction of the tank, you fire it, and it automatically homes in on the tank and then drops down through the hatch. And so, the Russians have taken devastating losses, as a consequence of this. And there's always, for the Russians, there's always a guy in the tank. For the Ukrainians, there's no guy on the drone. So there's an asymmetry to it. And so, Ukraine has punched way above the weight that all of the planners expected when this whole thing first started, because they've been very aggressively innovating in the field, for how this stuff works. And then, of course, again, the other tragedy playing out, but similar kinds of developments are going to happen in the Middle East now. And so, we get these amazing asymmetries. And so the Houthis, for example, are firing these, I think they're Iranian drones. They cost, whatever, thousands of dollars. And we'll literally, U.S. military will use like a $20 million Tomahawk missile, right, to like take down a $10,000 drone, right? And so, you have these like momentary, it's like slippage in time, right? These things shouldn't exist in the same era. And so if you talk to people in the U.S. military, they're like, okay, now we need to basically reinvent the whole thing. Yeah. Like the way that we field everything from aircraft to submarines, like all these things is just going to completely change. War in the future is going to look totally different.
Is the battlefield itself the place where this will have the biggest impact, or do you expect it to shape policy or deterrence or other aspects of geopolitics?
Well, it changes a lot. So the sort of most advanced version of the thinking, I think, is basically defense historically, like sort of warfare has been an issue sort of mass and sort of number of men, amount of material, right? So how many soldiers do you have, and then like how many tanks do you have? It's Napoleon, I think, once said God is on the side of the big battalions, right? And so it's like just like mass and force. Arguably, if you project this forward enough, what you kind of see a picture emerging is actually in the future successfully based on who has the best technology and the most money, right? And there's some connection between the best technology and the most money, because if you have the most money, you can either develop the best technology or buy the most technology. And so it sort of changes and by the way, it means like if you want to then be the strongest military force, you then want to be the strongest economy with the most advanced technology. It means it's like really strategically important for your country to actually win in technology, which is something that's sort of hotly controversial these days. And so like that matters a lot. Will you even have human soldiers at risk in the field or in planes or in submarines in 20 years? Like maybe, but I think probably not.
What does it take to win in this technology?
Yeah, so this is a very interesting. So this is sort of a very interesting topic right now for kind of U.S. politics. Which is like, so I have these. Technology has become a very politically loaded topic over the last decade for a bunch of reasons. And so I've been at our firm. We're much more engaged now in politics than we used to be, and I've been spending a lot more time in D.C. than I used to. And I sort of have these two very different conversations in D.C. It's called the Tuesday conversation. Tuesday conversation is it's us versus China, and then Iran, Russia, and so forth. And like this revolution is here, and the U.S. needs to be the dominant technology global superpower, because that's what's going to lead to us, being strong and protecting democracy and protecting our allies and all these other things. And so, what can you in Silicon Valley do to advance technology as fast as possible? And then on Thursday, I go back, and they forgot about the China topic. Instead, they're just focused on the U.S. and they're like, technology is like weird and scary, and like it's like freaking us out, and like AI is really scary, and like we think we ought to stop this whole thing, and like we need to regulate, and we need to like shut this stuff down, and like can't you people please slow down, right? And then I kind of say, well, like I repeat the Tuesday conversation on Thursday, and I'm like, could you please reconcile these 2 points of view for me? And they say, no, that's your job. So there's a real tension underway right now, and one of the
are those the same people or different people?
So sometimes they're different people. Sometimes they are the same people. It may surprise you to hear that sometimes politicians are not completely consistent from day to day. And look, both of the kind of give the devil his due. Like both of these impulses are very emotional, right? These are very emotional topics, because if you picture us losing a war with China, that's just devastating emotionally. If you picture AI, completely revolutionizing everybody's jobs and changing society, that's also very scary. And so, my conclusion is we as an industry are going to exist kind of between these two very, I would say, sort of emotionally valid, kind of impulses where people have a lot of questions and concerns.
You mentioned that technology has become far more political over the past years. What led to that?
Yeah. So look, I think basically, so I'll start by saying I think it's our fault. So I blame us, and by us I mean myself and my firm and my companies, and I think it's all your fault. Everybody here shares the blame. So look, like a lot of us who kind of grew up, in technology, grew up, engineering. My degree's in computer science. We sort of were like, wow, like we think the stuff that we're working on is like really important, and like we wish the rest of the world would understand how important it is, and now they do, right? Like they didn't for a long time, and now they do. And so I use the metaphor of the dog that caught the bus, right? Which is, the dog chases the bus, never expecting to catch it, and then God forbid, the dog ends up with the tailpipe in its mouth. Like, what does it do with the bus, right? And of course, the reality is the bus just keeps on going, and the dog is dragged down the street. And so that's us, right? We're the dog. And again, it's a consequence of like, okay, we won. Like the stuff that we're doing turns out really matters. It turns out software really matters, AI really matters, microchips really matter, the internet matters. Like these things all matter. And by matter, I mean these things don't just, they don't just matter to us. They matter to everybody. They matter economically. They matter culturally. They matter, socially. The runways, the spectacular runway demos, like, people in Hollywood are like freaked out, right? Because like, what does it mean to be entering a world in which movies can be rendered by AI, right? And what does it mean, for example, I'll give you an example, like, movie actors, like if the great movie actors of the past can have their images, being rendered in AI, for the next 1,000 years. Literally, is the future of the movie industry going to be Tom Cruise movies for the next 1,000 years? Kind of rendered over and over again in AI. Like, will there ever be any new actors, right? Or we'll just all be watching Tom Cruise movies. And technically, we're going to be able to do that. And so people in Hollywood are like super freaked out. Lots of people are just getting, I say, increasingly upset. There's a longshoreman strike actually that kicked off today. Where the guys, basically people who load and unload boats on docks, and it's like a flat out just anti-tech. It's just flat out, no more automation, like we're done. Literally, that's the strike, because no more automation, no more machines, we're done.
Do you think there's an angle here where AI levels up the discourse, helps improve the discourse, helps with governance, or is that, further out?
Yeah, look, it does. I mean, one of the things. So look, people see So start by this. One of the great things about AI is it's rolling out in actually a very democratic way, right? So, and if you think about this, like the way the computer technology rolled out like 50 years ago, it showed up in the form of like $20 million mainframe computers, and then it trickled its way down over 30 years to personal computers and then smartphones. One of the most amazing things about AI today is the best AI systems are rolling out to consumers first, right? And so, ChatGPT and Claude and all these things are rolling out to consumers first. And so, and this is one of the great things about technology is like, and that, by the way, the usage numbers are like, on fire. And so the number of just ordinary people in regular jobs, in regular professions, who are able to use ChatGPT or any of these systems today and are able to, ask questions and get guidance and figure out how to like deal with complex situations or deal with the government or navigate, laws or, figure out like all of a sudden everybody has like an AI they can talk to kind of help them through all these things. And so I think there's the prospect for sort of a general uplift of intelligence, basically of people having, a level of intelligence available to them at their fingertips that we haven't historically had. That certainly includes, politicians, policymakers, that certainly includes, people like military planners. Like everybody's going to have this sort of additional level. We used to call decision support systems. And so like, there's sort of a chance for everybody to kind of get smarter in a very interesting way. But, I would say that hopefully that means arguments can get a little bit more rational. But what that doesn't do is I don't think that dampens emotion at all, right? And I think there's going to be just tremendous amounts of emotion as this technology rolls out, as is already happening. Yeah. And so I just think like we as an industry are going to have to increasingly step up and explain ourselves and articulate what we're trying to do, and engage in the policy process and in politics, and really help people understand this. And by the way, also make sure that this technology stays democratic and stays open. One of the reasons like I think open source is so important is like I think it'd be very bad if this technology is centralized in the hands of a handful of companies. I think it's very important societally, culturally, that this is something that everybody has access to.
On the open source topic,
right.
Do you think how do you see that playing out? Do you think it could genuinely go in multiple different directions, or there's a, kind of an inevitable outcome here?
Yeah, no, so there's a real fight. So there's a real move underway to ban open source, and specifically open source AI, and specifically the math under AI, which is fairly mind-boggling for me as an engineer. Just in the
We're talking about linear algebra.
It's not that complicated, right? Like you're right. It's linear algebra. It's gradient descent. These are fairly basic algorithms. They're taught broadly in schools today. My 9-year-old is starting to learn this stuff.
Nice.
There are videos on YouTube that teach you how to do this. There's textbooks.
Yeah.
It's like half the kids at the Stanford freshman class are taking the Intro to AI course. They're learning this stuff. And so, but like there are serious, like the discussions in Washington are like disconcerting on this topic because they seriously, talk about this. And then, there's like outright bans, and then there's also just like sort of what I call sort of the potential for like this sort of stifling blanket of regulation. And the precedent for that is what's happened in the EU, where they have actually done this. They've actually implemented a stifling blanket of regulation, including most recently on AI. And the result is, they've effectively outlawed, to a large extent, they've outlawed technology startups in the EU, and the market has responded. And there's a handful that are really good, but there's not very many. And Europe used to be like amazing. Like half the great tech companies in the world used to be in Europe, and now it's down to a very small number. And so we have this like real life cautionary example of how this can actually go bad. And then we have a fair number of people in the U.S. and in California, which is amazing, who basically want to adopt the EU model. Yeah. And they're lobbying very hard to do that. Some of those people, by the way, are true believers. They really believe that there's like a profound societal threat or existential threat or various other kinds of threats. They really believe it, and you kind of see it in their eyes. And then, there's a bunch of other people that have commercial self-interest, right? And, they want to establish monopolies or cartels of different kinds, and they want there to be, basically government protection for their business. And so there's this like unholy alliance that's sort of formed up between these two groups.
So there's
and there was a real, we just had this real fight in California.
Yeah, and it's a very important role for policy to play here.
Yeah.
So this is the Ray Summit. This is an AI infrastructure audience, largely. Yeah. What does this wave mean for people building AI infrastructure, providing those capabilities? What can we learn from previous technological shifts that you've seen?
Yeah. So I mean, look, like it's going to be prime time. Like you guys are in the right field because this is it. Like this is going to be the big build out. And it's just starting, and it's going to be one of those things where we look at the stuff that we have today. We looked at it, 5 years from now, 10 years ago, and it's going to look like it was, belongs in a museum as compared to what's coming. And so, all of us here are going to play a big role in building that. And so this is going to be like absolutely prime time. There's an unlimited number of technical issues to solve, obviously. But look, on top of that, we're on this incredible voyage of discovery, I think, as an industry and of a world of, which of these domains of AI are going to be the ones that really take the fastest. Just give you this sort of here's like an amazing question that's playing out right now, which is the whole history of the, kind of AI robotics, kind of field broadly is that everybody assumed for a very long time, including when I was in school, that you would kind of get, you would get the low-level stuff first. And so you would get like robots that like pack your suitcase and like clean your toilet and cook you breakfast first, and then maybe decades later you would get robots that could like compose songs or like draw artwork, right?
Yeah.
And it turns out to be the reverse. It turns out it actually turned to be quite easy to get a robot to like compose a song or like draw artwork. It still can't pack your suitcase.
It turns out math is actually really hard.
Yeah, exactly. Yeah, and especially right the minute you intersect with the real world, things get very complicated. But look, the AI revolution is playing out today is mainly one at these sort of higher levels. Things involving basically software information bits. But I think the robotics, revolution is very close. And I'll just give you my favorite example of that. There's this company in China called Unitree, and they make a robot dog. Everybody's seen the demos of the Boston Dynamics kind of robot dogs, but you've probably never seen one in real life. Because they're just too expensive. They're like $50,000 and up. This company in China has $1,600 basically that robot dog.
So do you think
so there's this robot supply chain that's basically forming up in China like really quickly. And drones were kind of an example of that. Where China just like swamped the world with drones, and I think they may well swamp the world with robots, at least on the hardware side. And then there's all these questions around how to actually build all the software for robots, and Elon and others and lots of startups are working on that. And so it may be that we have the sort of bits version of AI revolution. It may be followed like almost immediately by the atoms version.
That's incredible. So there's a chance that the humanoid rollout will look more like a $20 subscription democratized versus a $20 million mainframe.
Yeah, look. So this company Unitree has they have I think it's a $50,000 humanoid now hardware, and if you just watch on their website, like they're advancing the sort of hardware capabilities like super quickly, and so it looks like the humanoid robots when they roll out, I don't know, mass market.
You're talking about to consumers.
To consumers. Well, the hardware cost looks like it's going to come in at, I don't know, $20,000, $10,000. Nice. And at that point, you can afford to have a lot of these things, right? And you can afford to have subscription models.
Yeah.
right? And so I don't know. I'm not positive how fast this happens, but it could actually happen very quickly now.
Yeah.
One of the very funny things right now is these robots. You see the demos, like so these humanoid robots, like they've got their control system, which is like the state of the art. It's like this reinforcement learning algorithm to try to get it to like crack an egg without destroying everything on the table or whatever. But then they've all got like LLM user interfaces with like voice now, and so it's like struggling to crack an egg, but it's like teaching you quantum physics, right? Like in like a plummy British accent, like at the same time, right? Yeah. And so there's this software kind of wave happening right now to try to like merge those approaches together, right? And have sort of multimodal models that are capable of reasoning and planning, and the new Llama release just dropped, I think last week, that has multimodal open source. And then OpenAI just released their O1, the reasoning and planning engine, which they say is going to get a lot better from here. And so like it may be that in a year we actually have a sort of single multimodal model that can do reasoning and planning that can power a robot, and then we're off to the races. It's
interesting to see how important all the multimodal capabilities are for robotics and real world stuff.
Yeah, and look, then what you're dealing with, then it goes back to the topic of this conference, then what you're dealing, so what made Tesla's self-driving cars work is they put 1 million cars in the road, they gathered all the imagery from all those cars, they used that to do deep learning, and then they made all the cars, really great at driving themselves, and they roll that forward, they compound it. But like we might be in a world within a few years where we've got 1 billion humanoid robots that are also gathering all that data and feeding it back and getting better. And so it may be one of the largest scale technical systems that we've ever built.
Yeah, that'd be incredible.
It might be very close.
Let's talk a little bit about investing in AI. So it's maybe a little too early to say who the eventual big winners in AI will be. Right. Has your perspective on that changed over the last few years?
Yeah, so there's this glorious, amazing difference between running a company and running an investment firm, and I'm gonna really, he's gonna be haunted by this for the next month, what I'm about to say, because he actually has to run one of these companies. When you're running a company, you have to have a strategy, and like it has to make sense, right? And it has to be like an actual, like you have to like lay it out, and you have to like have a conference like this. You have to show everybody what the strategy is, and it has to make sense. And if it doesn't make sense, it doesn't reconcile. People get upset. The one saving grace about on the investment side is we don't need one of those, and the reason is because we invest across a portfolio, and so we can invest across basically different approaches, right? And so we can invest in infrastructure and apps. We can invest in open source and closed source. We can invest in different technical approaches, and so we kind of fully take advantage of that. So I would say like a lot of the questions on the future of like the investing side, a lot of those questions become economic of like where's the value going to be, where's the revenue going to be, where's the profit going to be. I'll give you one of the very big questions right now, which is, are the large language models like OpenAI, are those businesses basically a race to monopoly and infinite profits because of scale, right? The biggest company is going to have the best model, it's going to answer all the questions better, and then they're going to charge whatever they want for it. It's going to have super high margins, be the world's best business, and basically, and that's like the track that that's what happened with search, right? Where kind of Google ended up in that position. And the answer is maybe, and then, or the answer is actually, are all those companies actually in a race to the bottom, right? In which it actually turns out, selling, intelligence is like selling rice or something, where it just turns out anybody can make an LLM. There's open source LLMs. There's new LLM startups every day. And it just turns out anybody can go scrape the internet, anybody can buy the GPUs, and then anybody can basically get the same result. There was a famous Google memo that leaked called, we have no moat and neither does anybody else, where they kind of articulate, basically saying if you have the same data, you get the same results, everybody has the same data. And so in that case, is it a race to the bottom? And by the way, there's some evidence that it's a race to the bottom because the price per token, right, of generated LLM output has dropped 100x in the last year. Yeah. Right, which is like much faster than Moore's law, which is the exact opposite of what you'd expect if somebody was going to, get a lot of profit out of that business. So, maybe that's a race to the bottom, and the term sometimes used there is a profitless prosperity, which is, like selling rice or any commodity. These companies will have a lot of revenue; they'll just have very, very low margins. I think sitting here today, nobody quite knows the answer to that. It also depends on things that happen. In the ecosystem, I think like, Meta, where I'm on the board, the release of the Llama, I think open source models has really changed how the future is going to unfold. Because having fully competitive open source, I think really changes things. And so there's really big questions around where the value capture is going to happen, and we're actually trying very hard to not prejudge that because I think we actually don't know yet.
Makes sense. I mean, the fact that a lot of AI startups need to spend a lot of money on GPUs, right. How does that factor into your investment decisions? Yeah, so that's by the way, the Peter Thiel thing. The Peter Thiel thing is, we're all wasting time with all these software companies, right? We should just put all of our money into NVIDIA, and call it. And by the way, for the last 10 years, that would have been a very good strategy.
And so and the model there basically is NVIDIA will soak up basically the entirety of all venture capital invested into AI startups, plus all revenue that those startups generate, and they'll just capture the whole thing. And by the way, there's a picture of the world where that actually that's what's happening today, right, for sure. And then there's a version of the world where that happens for many years to come. And that argument basically says NVIDIA is way ahead on the technology for the chips, and then on top of that, they've got all this other technology like CUDA, so they've got this incredibly, kind of strong, kind of technology lock-in. So that's one argument. The other argument, though, is what traditionally has happened in the chip industry is leads like that last for a while, and then they generate a huge profit pool that draws competition, and market forces kick in. And then you have every other chip company in the world, from AMD to Qualcomm to Samsung to the Japanese companies and everybody else, and all the startups. And Cerebras, I think, is going public this week. And so you have lots of startups, and you just have lots of people who are like, wow, I want a piece of that pie. And by the way, another argument on that would be GPUs. GPUs were not originally developed for AI; they were developed for graphics, right? And if you were developing chips from scratch to just do AI, they might be very different chips. Yeah. By the way, Google has their own chips. Amazon has their own chips.
We're seeing an explosion there.
Explosion of chips, and so it may be in 5 years from now, NVIDIA is still a great company, but they're part of the ecosystem, and it turns out there's 5 other big companies and 10 other startups and a whole bunch of other approaches that make just as much sense. And then again, you might have big revenue growth in the chip industry, but much smaller profits. And so, but again, none of these things. One of the things that's hard to forecast these things is it depends on what people do, right? And so, what decisions are made today at the other big companies, and what decisions are made by the startups and VCs, and by the way, customers and users, and all the people building around this. What do they all want? And so we're kind of on a collective mission of discovery to figure that out.
Maybe to wrap up, for all the future founders and current founders in the audience, do you have advice you'd give them about starting businesses or running their business in today's environment?
Yeah, so I think the big thing on starting a business, I think the big thing is starting a company, the advice is kind of always the same, which is it very rarely makes sense to just say, I want to start a company, therefore I'm going to go in search of an idea. The great companies, at least in tech, usually what happens is they're started by somebody who has been deep in the field of what the startup is doing for probably many years earlier. Before. They're probably very deep domain experts. And by the way, this gets glossed over a lot. A lot of these successful tech companies in the Valley, they kind of have these mythological founding stories where it's like, I was just a little kid and I just had this idea and it all worked. And it's like, well, no, I was in a lab for 10 years before that, right? Trying to get this stuff to work. I was at school. I worked for a big company. I worked for another startup and I learned everything. And so most of the successful startups come from people who have spent 5 or 10 or 15 years deep in the trenches, really deeply understanding the nature of a problem and figuring out a better way to solve it. And so I think there's probably a large number of great startups that are going to come just out of this audience in the next decade. In terms of how companies operate in this kind of rapidly changing environment, our big advice always is basically run experiments. There's always this kind of daunting, thing whenever you're sort of responsible for an existing business. I've got all my existing customers, my existing employees. I've made all these commitments. Doing a new thing always feels kind of weird and scary because it's like, what if it doesn't work? And I'm, going to really break what I have. And so what we always sort of advise is the right way to do that is try to figure out, try to run the smallest possible experiments to kind of try to prove a hypothesis. Take a small number of customers or a small segment of the market and explore. And then, by the way, try to make that a habit inside the company. Try to run lots of experiments like that over time.
Seems like generally a good practice.
What's that?
It seems like generally a great practice.
Yeah, exactly. Yeah, exactly. And basically build option value. Learn as you go. But without having huge downside risk as you run the experiments. And then when you tap the vein and you think you figured it out, that's when you commit the business.
Marc, thank you so much. Really appreciate all of your insights.
Good. Awesome. Thank you, everybody.
Thank you.
Thank you.
All right.
Excellent.
Thank you all again for being here. This is the end of the keynote section. I'm very excited to meet as many of you as possible in person, and please enjoy the rest of the conference. Thank you.